Hi, everyone. Thanks for joining us today. We're just going to wait a few minutes for folks to join, and then we'll get started. All right, it's 2 minutes past the hour. So thank you, everyone, for joining us today for this RAIN RFID radio regulations webinar. Just a few logistics before we begin. We anticipate this presentation will last approximately 30 minutes, allowing 15 minutes for questions. Please kindly submit using the chat box on the control panel on your screen. Questions will be answered at the end of the presentation. Additionally, the call is being recorded and it will be made available to the public following the close of the presentation. On behalf of the RAIN Alliance, I am pleased to introduce to you Joe, Head of Regulatory Affairs at the RAIN Alliance. Thanks, Joe, for joining us. I'll turn the webinar over to you now.
Yes, hello, everybody. I'm Joe Flügel, Head of Regulatory Affairs for the RAIN Alliance, with a particular focus on radio regulations. When we talk about radio regulations, we talk about the RAIN RFID frequency bands that are spread between 865 to 928 megahertz globally. As you can see on the screen, there's most of them like Japan, Australia, Upper European band, China, and certainly Brazil, United States are between 900 and 928 megahertz. Europe and a few other countries have a band at 865. And the European band at 915 is rather new. We have 4 channels here. Actually, in most regions, there are only 3 channels because in this spectrum range of the 4th channel, there is railway use. The European 915 band is basically rather new compared to all the other frequency bands. And in the last 18 months, we could get lots of success in respect to the adoption of this band. So what you see here on the screen with all the green marked countries, they're all allowed in 915 to 921 megahertz band already in Europe. Some countries did not report it back to the European Commission level or CPD level, but the national implementations are available. On the webpage listed below, you see all the details and all the links that you require to get the details. You still can see on the map a few countries that are not yet marked green. These are a few countries that are marked yellow, where it was not possible yet to get updates. These are certain countries, in particular, very small countries that sometimes even don't have staff to maintain this. And we still have 3 countries where we have military use. This is Germany, the Netherlands, and Greece. We are in communication with all those countries, understand the issues, and working with them, trying to find solutions. It will take some time. It's not something that is thing that works straightforward, but the communication is ongoing, and maybe sooner or later we'll have a solution for those countries as well. What is the value of the Upper European band? The Upper European band has lots of benefits, and that's really the reason why we are pushing for it. The first topic is the frequency. In the lower band, we have 865 to 868 megahertz. In the upper band, we have 915 to 921 megahertz. In this frequency range, this basically overlaps what you have seen on the slide before with the most international frequency bands. So this makes then global product design, in particular global tech design, much easier, because the frequency range overall get smaller. A second very important topic is the reader transmit power. So it could be increased from 2 watts ERP to 4 watts ERP. This means 40% more read range, and for instance, also significantly more read range than currently in the United States under FCC with 4 watts EIRP. Then the next topic is transmit channel width. In the lower band it's 200, in the upper band it's 400. So this means the double of the communication speed from the reader to the tag, and it would basically be the fastest communication speed globally available. Similar than the reader channel spacing, which has been increased from 600 kilohertz to 1200 kilohertz, it doubles the communication speed between tag and reader, and also takes care that we have less interference in case of multiple systems deployed. In respect to multiple system deployment, there's also the topic of the number of channels. While in the lower band we have 4 channels, we basically have 2 pairs that we can really use it in that way. They are not completely independent. While in the upper band, although we might only have 3 channels, they have a higher distance, so the interference overall would be lower. And finally, in Europe, we have a limitation on the tag backscatter power. This is actually globally unique, that the tag backscatter power is limited. In the lower band, it's 10 microwatts. In the upper band, it's 100 microwatts. So this is 10 dB more and makes it much easier to make the system design, and also in respect to reader sensitivity, it makes the design easier. So in order to move forward and ensure that the administration, when more and more administrations allow the 915 band, it's also important to use the 915 band, because only if the band is really used, then it will remain available. And yeah. The next topic is UHF RFID spectrum for newbies. I guess all of those deploying RFID systems globally do this in countries. They look for the radio regulations and they do it. However, we have around 200 countries on the globe, and around half of them actually have real UHF RFID spectrum definitions. Certainly bigger countries have them, but smaller countries do not have them. And so as a RAIN Alliance, we provide support here and help those countries to basically develop a frequency plan, a spectrum allocation plan. And we provide here documentation, the link you see in the bottom. And whenever somebody asks what to do, where to set up a spectrum for RAIN RFID, we clearly say the preferred band is 900 to 930 megahertz. Certainly the band shall be as wide as possible. And if available, then the GSM gap, so like in the upper European band from 915 to 921 megahertz shall be used. The reason is that this gap, this band, might be widely available, so this is the easiest move here. Depending on how much spectrum is available, we recommend different methods. So for below 2 megahertz is basically what we have in the European regulations in lower band. If it's up to 8 megahertz, then it's like in the European regulations in the upper band. And if it's more than 8 megahertz, then like 500 kilohertz channels frequency hopping spread spectrum, as we have it in the United States. For 8 megahertz, this would work if the band is more or less exclusive for RFID. If it goes then beyond 20 megahertz, then certainly this would also work if other applications use the band. In respect to transmit power, we recommend at least 4 watts EIRP. This is the definition as it is, for instance, used in the FCC in the United States, or at least 2 watts ERP. This is the definition as it is used in Europe. Those values are basically the same. There's a 10% effective difference than in read range for the tags. Good. As RAIN, we definitely work a lot in respect to the regulations. Myself, I am the chair of the ETSI ERM TG34 group that is responsible for UHF RFID. And we have updated the, I guess, well-known test standards VO228. It has been published the end of last year. We have some delay here in the citation in the EU official journal from the European Union. So now we're waiting already 9 months. We hope that this moves forward, but this is definitely then the next step, the next important point to make this document then available for real certification. What we again do, although we just on the way of basically on the way waiting for the citation of this version 341, we already planning the next revision, in particular to update it with regarding the test methods in the technical report 103977. And the reason is development measurement techniques are moving forward, and there's certainly demand and has been new methodologies that could be applied to make measurements more efficient and make the latest equipment better suitable for measurement methods. There's something else where the RAIN Alliance has been deeply involved in the last couple of months. This is the United States FCC petition for rulemaking. To briefly recap this, so the FCC band for UHF RFID, RAIN RFID in the 902 to 928 megahertz band is available for around 35 years. And then around 30 years ago, there was a change to allow additional systems. And one of those bands with the systems for positioning systems was acquired by NextNav, or the daughter company of NextNav. And NextNav requested or proposed a petition for rulemaking on April 16th this year. And this was out. And then beginning of August, the FCC announced the public notice, and the Office of Engineering and Technology was looking for comments, and the deadline for these comments was on September 5th, and then there was a deadline for reply comments, which was on September 20. Certainly, all this was a surprise for RAIN users and other users of this frequency band, because this was more or less stable for 30 years. And in this petition for rulemaking by NextNav, they basically stated they would like to have around half of the 902 to 928 megahertz band for LMS, so location and monitoring systems, and also 5G. So the LMS was actually granted already in 1995, but in respect to the LMS not really utilized. Now they would like to change this and additionally use this band for 5G. And they stated they would like to get priority of over FCC Part 15 devices, including RAIN RFID. This is also an unexpected request, because while the FCC band for RFID, this time it was not really RFID, was set up in 1989. And when the LMS systems were allowed in 1995, the requirement was clearly that they do not interfere with the existing Part 15 devices. Another excerpt from the filing here is that the lower 900 megahertz bands, how they call it, is currently underutilized. And so they also see here the chance that using it for 5G would be an option. However, I mean, this the addition for a rule change and then the request for comments and reply comments initiated then lots of comments. So we had nearly 2,000 of them. Also, the RAIN Alliance provided a very comprehensive comment. There was a comment from the NTA, so the agency of the US Department of Commerce, which is important because this might impact then how future steps will develop. But basically, from all those comments, including NTIA, nobody was basically supporting the petition at this point, except less than 10 filings that would support this. This was NextNev with multiple filings, and mostly organizations that have a link to NextNev or basically have licenses similar to NextNev. So in total, we had around 2,000 comments or nearly 2,000 comments, and less than 10 are really supporting this petition. NextNev also gave reply comments. So reply comments are there to comment on filed comments and questioned a couple of Part 15 technology user inputs, including RAIN, but however, not providing inputs to allow to work on. And again, they pushed to have the priority. So as a RAIN Alliance and several RAIN members, we had a look into this and reviewed not all these 2,000 documents, some of them are 60 pages long, but a few ones. And I would like to address a few points that have been addressed here from the RAIN Alliance. So the first one is the argument of underutilized. If you follow the RAIN Alliance announcements, or you have been in Florence last week, there were 45 billion chips in 2023 on RAIN RFID chips, and we expect 55 billion this year, and 40% of them are used in the US. So this is really significant, and underutilized is probably not at all suitable. I guess there's not any other technology that has so many items issued per year. And then there are major applications that are impacted, like resilient supply chain in multiple sectors, including certainly retail, on defense, logistics, tire tagging, healthcare, livestock manufacturing. There are so many major applications rolled out already that use RAIN RFID. Then we also raised the point that their submission, in particular, comparing this to 3GPP, is to a certain extent outdated, because they refer to the release 15, but the current release is 18. And this is obviously superior to the proposed NextNev technology, in particular in resolution, as a position resolution. And certainly there is also a rather formal topic. The adoption would cause violation of the Commission's statutory duties under Section 309 of the Communications Act. So assigning as 5G band to one particular company is not the way. We all know the terms of auctions that are ongoing, usually. Good. Let's go briefly into the comments that RAIN did. So we did lots of communication calculations here, and yeah, we can go through all the maths, and these are characteristic parameters here, and the NextNev questions, because in the RAIN Alliance analysis you use 100-meter base antenna height. This is from 3GPP documents. This is from the FCC documents, and they said most antennas are lower. I mean, you see here the link to the calculation model. You can reduce the antenna to 50 meters, 30 meters, 10 meters. Yes, it will be a little bit less, but it will be still many kilometers on distance that is required. So the antenna height itself does not solve the problem at all. So this comment was not really suitable, and in particular, there was no input available that could be used for additional calculation. Was just saying it's less than 100, but nothing else. And the second topic here is when we say, okay, how do RAIN readers impact the NextNav mobile devices? So the other direction, we had assumed based on the 3GPP standard, certain values based on the NextNav edition. And what is important in the feedback, in the reply, NextNav confirmed that our assumptions of their sensitivity are correct. So these calculations are basically confirmed. On the other hand, NextNav did not believe that RAIN readers are typically the sensitivity of -80 dBm. And the reason is because there's the forward link in RAIN, and currently good tags have probably -25 dBm tag sensitivity. And this was basically the assumption that NextNav took. But as we know, it's a passive technology. So we have to consider the tag backscatter loss and then the path loss on the return link, which makes -80 dBm and not the assumed -30 to -40 dBm that NextNav put in the comment. Good. I looked then into a few comments from others. So Itron, or with different names before, like Silver Spring Networks, they're using this band already for many years. I would say at least as long as RAIN RFID. And just to highlight a few comments here. So Itron said, okay, NextNav promised to basically go ahead with the business plans already 13 years ago. There's lots of documentation already available on the petition at this time. And they clearly say that the Commission, so the FCC, should review this proposed bargain, and they call it bargain, and they certainly think this is not the right way to do it. Also stating the Commission should not reward NextNav's failed business plans with a windfall. So NextNav or the previous owning companies have disbanded already. I guess 1995 it was assigned, and the auction was a couple of years later, so around 25 years, and there was no progress yet. And also Itron as a smart meter company and this kind of company clearly says there was no feedback, no communication with NextNav to solve this interference topic. And certainly they also comment there's a lack of technical analysis on the whole thing. TransCore, very popular in road tolling, clearly has concerns that NextNav proposed the elimination of the safe harbor. And Neology did a more business analysis and stated this might be a multi-billion-dollar spectrum windfall. And there's also the Resilient Navigation Timing Foundation. This is a research organization, more or less, and they clearly said their solution for TPNT, how they call it, so this terrestrial GPS, without requiring new changed spectrum. So the NextNav solution is obviously not the only way to do it. And also they say the technology is not unique nor universally accepted. And they list in their feedback also other solutions or combinations of systems that could provide similar capabilities and would solve the problem differently. Let's go briefly the NextNav input document. What is important here? So on the one hand side, they call it NextNav and the other LMS licensees. There's a little bit a difference between LMS licenses and other LMS licenses. And so in their proposed input they submitted in June, they made a small change and to remove non-multilateral LMS operations. Because the point is that non-multilateral LMS operations have some benefits, but the only multilateral LMS systems does not have this benefit. And so in this way, and what NextNav falls in the second group, they would like to utilize the benefit from the others, but this is certainly something that has been put into the FCC regulations in 1995 that should not be the case. And the second point is they clearly would like to have a change in the paragraph 9361, interference from Part 15 amateur operations. And yes, they may not cause harmful interference, yes, but here they would like to remove this one, that the exemption that Part 15 devices are not seen as harmful interference if they fulfill certain items. So this is really the major change, because in 1995, these LMS systems were only allowed in the frequency range because of these important inputs in Part 90, and it's Part 90 and not Part 15, but LMS systems have to fulfill Part 90, and this is the point. And if you move forward, so this is the full paragraph here. It clearly says these operations will not be considered to be causing harmful interference, and to these multilateral LMS systems, so to NextNav systems, if certain things are fulfilled. First one is not employ an outdoor antenna, so indoor. So this also means if a NextNav mobile would move into a shop or something like this, it would be maybe impacted by an existing RFID installation, but that's the way. The petition asks the other way around. If a mobile moves into a shop, it needs to be turned off, because we learned before there's 1 kilometer distance requirement. And then in case of outdoor antennas, we have this very known 6 dBi antenna gain, yes, and 5 meters height. So the current regulations clearly limit the LMS systems here and provide a very good protection or priority on Part 15 devices. So this multilateral LMS has no superior rights to the unlicensed users. This is very clear. This is a clearly defined thing. It has been introduced in order to allow those systems to use the same frequency range. And this had a very strong background why this was in, and it's probably not appropriate to remove it. Also, topics that popped up in the media, I just take one. So NextNav calls radio spectrum grab to privatize 900 megahertz. There are lots of statements around what this means, but this is just, you can click on the link and read all the documentation here. Good. So in RAIN itself, we have the Radio Regulatory Advisory Committee that supports my work as head of regulatory affairs. And here we discuss, get feedback on upcoming things on radio regulations. We coordinate the efforts. And we have some upcoming work is certainly to monitor all the things in respect to the US FCC petition for rulemaking. And also we work here a lot on ideas for improvement of radio regulation standards. There's a general webpage, and for those who are RAIN members, there's also a Basecamp. And if you don't have access here, just drop me an email or the operations team, and we can add you to get access. So what I'm planning here now is next steps here as head of the radio regulation affairs. In Europe, there's something on SRT to satellite communication. This is a topic we need to monitor. No particular action at this time required. Then certainly work on the remaining countries on the 915 band. So the momentum is there, so let's see. And then certainly monitor again the FCC beta edition. And globally, we are working here on defining UHF RFID regulations for missing countries. So whenever you go to a country, want to install an RFID system, and you see a gap in the regulations, just drop me a note and we're gonna have a look into this. Certainly promote the 900 to 930 megahertz band, or at least a part of it, and general support on radio regulations topics. For instance, Australia, they just announced a week ago, there will be an opportunity for change. There are also actions for all the RAIN members and RAIN users. It's important that you support the RAIN community to inform local European regulations authorities about this leaflet, about this information. Certainly talk to Germany, Netherlands, and Greece. Then inform local newbie regulatory authorities about leaflet on UHF RFID bands. So this is also available on the RAIN page. And yeah, contact me in respect to any regulation topic. And very important feedback on potential improvements of the radio regulations. So we have Australia, certainly also Europe. And yeah, if you find anything you would like to improve, let me know. And certainly promote the new radio regulations page. It's available already for probably half a year. Lots of information about the changes in Europe in respect to 915 band, link to the radio regulations, because sometimes you need then to have the link to the right document also in the European country, and also a link to the global overview that GS1 provides. Good, and very important, again, use the European 915 band. Good, thank you. That's all from my side. I see a few questions. Let's try it with the serious questions. So the first question was, what is the advantage over FCC, especially for countries which only have, say, 6 megahertz bandwidth? The advantage, now 6 megahertz is the new European 915 band. The advantage here is that in Europe, you have dedicated transmit channels, 3 or 4 of them, and dedicated channels for the tag responses. So separating them also in the regulations provides less interference and could increase the performance. In particular, for the European 915 band, we have also higher bandwidth and higher power, which is an additional benefit. In FCC, you have this 26 megahertz with 52 channels where you do frequency hopping, and but there are also many other applications using the same band, like Wi-Fi, smart metering. The next question is, are there benefits to have an exclusive band for UHF RFID? What issues exist with obtaining or having an exclusive band? There are indeed benefits of having an exclusive band, because an exclusive band means that you know how other RFID systems work, and it's much easier to coordinate. And actually, the dense reader mask, as it is defined in ISO 18006-3 and Gen 2, clearly defines how this works, and you have basically the minimum of interference, and this is definitely a strong benefit. The reason is why we do not have exclusive UHF RFID bands in certain countries is clearly because when this was set up, there were other technologies going in this band, and now spectrum is a very valuable asset, and it's very difficult to find new bands. Good, then the next question. I followed the implementation of frequency bands for RFID in Brazil for more than 20 years, reducing the number of hopping channels and maintaining the spacing of 200 kilohertz between them. It has no significant practical impact regarding the number of readings, power, etc. And unfortunately, because it is unique, RFID reader manufacturers have to adapt to Brazilian frequencies. If any of these countries use a part of the frequency band used to date for RFID, firmware updates and for new readers will have to be adapted. I followed the Brazil regulations. I thought there's a similar overlap with FCC. Certainly, some part of the spectrum are not available for RFID, but the channel width is similar. And in respect to the 200 kilohertz spacing, I'm not, this is something new for me. I would need to investigate because in FCC, we certainly have around 250 kilohertz reader transmit channels because the channel width is 500 and to have the other 250 kilohertz available for tech responses. There's no plan as in Europe, but there's a practical plan, and this is also defined in the advanced reader mode in the ISO 2006-3. Good. Then the next question is, when can we expect to see the EU countries allow the 915 band at 2 watts ERP, and will we see this reflected in the ETSI specification? Yes, it is available except Germany, Netherlands, and Greece today, and is also available in the ETSI specification, so the EN 30228, 341, and even the previous version 331 already fully addresses both bands. Do you know if Walmart submitted a comment opposing the NextNav petition? To my best knowledge, I did not find anything from Walmart. The presentation will be available for download. Yes, I think Elizabeth will address this later then. Then how does the USFC arguments impact countries which specified FCC use? That's a good question. In practical, and I'm referring here to Canada as an example, and there's the system design guideline available on the RAIN webpage under the material resources. Not really, because for instance, Canada follows the US plan, but it is based on legal documents that are available in Canada. So if FCC changes the content, it does not change the content in Canada, for instance. And I assume that most other countries do it the same way. Good. Another one, we see some significant interference in 915 to 920 megahertz band in some European countries, for example, Sweden and Poland, MORS. What is usually the main source of interference in this scenario? I would appreciate if you can send me more details. We certainly would like to have a look into this. We have seen in the past that devices for other applications have a setting issue. And the other point is that there might be, for example, LoRa devices as one of the short-range devices. And if those would select different channels, which is easily possible, or even RFID could do this, then this interference usually is resolved. And then another one, how does environmental interference such as metal or water affect UHF RFID performance? I mean, metal reflects, so if an RFID tag is behind a metal surface, it's very hard to read. And so certainly also water is attenuating RFID. So if you would like to read an RFID tag, which is on the other side of a pallet with water bottles, you will also see performance degradation. However, the RFID tags increase their performance by around 1 dB every year. So today we have minus 25 dBm or so sensitivity. So reading through more water or challenging materials is getting much better. Certainly metal is a reflector, and if this has a certain thickness, then you can't go through the metal. You could only benefit that there's some reflections that supports you to get more or less around the metal. Good, another one. As always, was a follow-up question specifically related to tires. I mean, there are good solutions on RFID in tire stacks, so there are specific performance standards available on the ISOs, for instance, ISO 2912. And they define this. And yes, I think there's good knowledge available on how to design RFID tags to be embedded in tires, and the issue is basically solved. Good. That's all I have received on questions. Is there any remaining questions? Otherwise, I would like to basically get back and ask Elizabeth to continue.
Yes, thank you so much, Joe, for joining us today. That was a very informative presentation, and thank you all for your time and your continued involvement with the RAIN Alliance. As mentioned before, this presentation will be made available on the RAIN Alliance website within the next business day. So thank you again, Joe, and everyone have a wonderful rest of your day.
Good. Thank you for your participation. Bye.